Hello everyone and welcome to another OrCAD X how-to video. My name is Adam, and in this video we will give a brief overview of topology exploration in OrCAD X 25.1. Now the main function of topology exploration, or commonly shortened as TopXp, is to extract signals not in their ideal form and to simulate them. We want to see how they exist in the current layout or the current topology of the board that we are working on. Now, analyzing a signal in such a way will give us results such as the time domain waveforms, eye diagrams, and plenty of other useful analysis parameters. So to begin, I have a board open here. This is the Brainboard project, which we commonly use for these types of demos. Let's go ahead and launch the Analysis Workflows tab. So this is found under Electrical Analysis and select Analysis Workflows. Now in here, if you look at this dropdown, you have plenty of options. And here we have an option called Topology Extraction Workflow. Now these workflows essentially work by helping you follow the steps from top to bottom. So if you've already run a topology extraction before, and you've maybe saved those settings, you can load them and reuse them again. Or if this is your first time running it, then you would want to start at this design setup section and then work through each link as it kind of takes you into the different steps that you need to take in order to set up your analysis correctly. So let's go ahead and start by clicking Design Setup. So this will take us into the Design Setup workflow. Not a problem. This general setup is essentially what you would do in your layout process, right? So you would define the materials, your cross section, you would set up all your components on the board, you would route them, assign your differential pairs, get your constraints all done. What we are looking to do is to now do this component model setup. So we'll click on this Setup Default Models. So here we can see the default IBIS models for pin types of in, out, and bidirectional/other. And this is for both single-ended pins as well as differential pins. And we can double click on each of these and bring up the default model browser. And then from here, you can simply just go ahead and select what type of model you would like to use. So for this example, we will be setting them as follows, and we will use a little bit of editing magic. So I will go ahead and quickly set these to what they are supposed to be for this example. Okay, once we have finished assigning all of our models, we can go ahead and click OK. And then the next thing that we need to do is to click this Assign Models section. If you have a library of models, you can also manage your library through here, but we aren't going to assume that you are starting fresh. As you can see, there are no models in my design. Now, in the model assignment window, you can view the status of all the devices in the design, as well as whether or not they have a model assigned to them. You can see that there is no assigned model, so the status is now model found. If we were to have a model that's already been assigned, then this would show as green and it would say validated. So what we'll do for this example is we'll find here U20, and we will go ahead and click on this Create Model. Now in this create model window, you can see the, for example, estimated pin pair parasitics, and you can edit these values as well as all of these different pins down here, whether they're set as, bidirectional input or output. We set our defaults earlier in the set up default models section. But here, if you wanted to change something, you could do so as well. But we'll just go ahead and click OK. And now we see that this model has been validated. Likewise, we'll do the same for U2, as those are the two components which we are working with. Again, same idea. If you wanted to change any of these values from their defaults, we can go ahead and do that in this window. Let's go ahead and click OK. Once we're done, you can assign models either to your entire design or simply to the components which you are interested in analyzing. Once we're done, we can go ahead and click OK. Next thing we need to do is simply click Save Design. Go ahead and save your design. And then we can jump back into the Topology Explorer workflow. So once we've done our design setup, if we have multiple layouts, we can do that here as well. But the next thing that we need to do, and you can see that there's an X here, meaning that we will not be able to start extraction until we've actually selected the net in our design. So I'll click that. And for this example, I am going to use DDR DQ9. Let's go ahead and add that to the list here. Click OK. So once that is selected, we can click on View 3D Geometry. This will give us a nice preview of what the topology actually looks like in the physical view. So we can see that there is a pin on the top layer here and a set of, a single via coming down into one of these layers and then being routed across that layer and then coming up to the other pin also on the top layer. Let's go ahead and close this view. So there are also some additional options under Setup Analysis Options. Go ahead and click on that before you run your extraction. Again, these are going to depend on exactly the specifics of the type of analysis that you want to run. You can look at the different tabs, for example, setting the minimum coupled length that you actually want to analyze. Once you're ready, go ahead and click OK. And then we can go ahead and click on Start Extraction. Now this will launch Sigrity, so you should expect a new window to launch. All right, so once we see the topology workbench window pop up, you can see the entire topology mapped out from the driver, for example, through the trace to the via, to the trace on our internal layer, to the via, coming up to the trace on the top layer, to the pad of our receiver. So from here, we're ready to essentially analyze our signal as it exists in our layout. All right, so that is it for this video. Thank you so much for watching this quick overview on how topology extraction works in OrCAD X. If you have any questions or comments, please feel free to leave them below. Or if you have any suggestions on what you would like to see in a future video, please leave us a comment as well. In the next video, we'll take a look at how we actually take the extracted signal and run some simulations on it. See you in the next one, and thank you for watching.